So we've got some stuff to finish up. If you were gone, you're going to want to come back and see me on that. Just really quickly, I've got, oh, that's way too early.
Yeah, we were on like a problem. This matrix multiplication is what we were on.
No, wait. I was not gone. I don't think we did 8.2.
Yes, we did.
We did 8.2 and 8.3 on the same thing. Okay.
Okay, so here we go. There's where we're at. Quiet down, please. I want to multiply these two matrices.
Yeah, that's what we're
Do
doing.
you remember the rule?
Yes.
Yeah.
What does the rule say?
They have to be the same height.
The insides have to match. And when I say the insides, I'm talking about the insides of the dimensions, right?
Yeah.
So this is the first is a 2
by 2.
by 2.
It's a 2 by 4.
The second is a 2 by 4.
So you're gonna get a 2 by 4.
The two insides match, so I can multiply these two. And I'm going to get what's on the outside. So I'll end up with a 2 by 4. And I'm going to do that for you now. So we got 2 by 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay. Now it's going to be kind of weird at first, so please ask questions if you don't understand where these numbers are coming from. Okay?
Okay.
You got questions already?
I did. Maybe I was here.
Good. That's even better.
Are we seriously
So,
just gonna do this?
do you guys remember the coordinates of every element?
Yeah.
Would have like row column. We're going to use that same idea to figure out what we need to multiply. Okay. Let's start with the first spot. I'm going to start here. This is
2.
row 1, column 1, right?
Yeah.
That means back in my matrix, I'm going to multiply row 1 by column 1 of the other.
Oh, okay.
I'm going to multiply row 1 from the first matrix by the column 1 of the other. And it's going to go like this. 1 times 2, how much?
2.
2. Plus 3 times 0.
Which is 0. So it's 2.
That gives me 2. 2 goes in that element slot. So you're doing kind of a shifty thing there, okay?
Yes. I get it.
And how did you discover this?
I didn't discover it.
No, not you, but like, okay. Wait, on the
I don't know the history of this one, but probably, I don't want to say, probably Gauss figured it out. He did a lot of matrices. Right, so row 1, column 1, right? This is R1, C1. Actually, no. Yeah, we could call it that. But this is actually just 1, 1, right? First row, first column.
Yeah.
So I take the first row with the first column. Okay?
Okay, I get it. So then,
Anyone okay with the multiplying, what I had to do?
yeah. So we're just gonna do
Okay,
that for
so
the
it'll be
rest of
this
right?
with this, and then it shifts. This with this. Now, what's really cool about this
Just do that for
is you can multiply anyone you want at any time. So like if I wanted to do this one right here, what is that?
Yeah, it's row 2, column 3.
That is row 2,
Column 3.
column 3. Row 2,
Column 3.
column 3. 0 times negative 1,
0.
2 times 4.
8. That's easy. 8.
Okay? Now that's just kind of a fun thing, but you really want to get used to just doing them straight across if you want. It's up to you. I like to shift sometimes just to keep it interesting. No, I don't.
We just do it for the fun.
All right, so let's go ahead and do the next spot over. That's still row 1. So I'm going to stick with row 1. Let's go to column 2 now. So 1 times 3 is?
3.
3 times 5 is?
15.
That gives me
18.
18. Let's do the next spot. What do we have? Negative 1
And
plus 12?
So it's 11.
Yeah.
Yeah.
If I need to slow down for anybody, let me know. Yeah, slow down. We're doing the next one already, so that's column 1. Sorry, row 1, column 3. We're in row 1, column 3 right now. So 1 times negative 1 is negative 1. 3 times 4 is 12. That gives me 11. That goes here. Go for it.
I forgot. How do you know what the product, the size of it? How do you know the size of it?
Dimensions, rows by columns. This has 2 rows, 2 columns, so it's a 2 by 2.
No, like when you multiply.
Oh, if the insides match, you'll get what's on the outside for dimensions on the answer. So it'll be a 2 by 4.
Is that two? Oh,
you try to do the next one here. Do row 1, column 4. Do row 1, column 4.
Said 9.
No, for like
Nine.
oh, I gotta do a scrub.
My hand hurts.
Your what hurts?
My head hurts.
Should take some ibuprofen. Aspirin. Your what hurts? Say heart hurts. Why?
What'd you get, Catherine?
That's what I thought.
I got 9
9.
for the fourth one. Yeah, I got a 9 for the fourth one.
Yeah.
Good. I just want to make sure I got enough bobbing heads before I said yeah. All right, let's go to the next one then. So now we're in row 2, right?
Yeah.
So everything is going to be multiplied by this one. So what goes half?
0.
0. And then we got 0 times 3, so it'll be what, 10?
10.
And then the last one would be 1.
0 times 3 is 10.
Wait, hold up.
Yeah.
You said 2 times 3.
One, and then we put 2.
What?
Question, wait, you said 0 times 3. What do you get?
Oh, 1 times 2. I thought I'm sorry. Did I say the one out loud?
What do you get to multiplying 2 by
Sorry.
5?
So it's 1.
0 times 3.
No, it should be 2. Because row 2, column 4, 0 times 6 is 0, right?
Okay.
And then the 1 times the 2 gives me.
Okay.
That's what was in my head. It was 1 times.
You said a whole different number, but you wrote a different number.
No, here's the bad thing. Like sometimes I'm doing problems. I don't do it as much anymore. But I would be doing problems and I'd be spitting out answers as I was writing here. But it wasn't one that I had. But they already, like, students would know the answers because I already spat it out. And be like, oh, you just said it. Like, oh. All right, try that again. I think I have another example.
Can we do it by ourselves then?
You'll get to do it on your independent practice.
Oh, thank you.
I'll wait for a little bit. Looks like we're good. All right, let's see here.
Yeah.
Can this one be done?
Yeah.
I just flipped it to, right?
Kid,
It can't be the
did you see
What?
Is it the end?
two by 4 and 2 by 2, 4 and 2.
Ah. So so in this case we did A times B.
I don't have a green set.
Oh, well, sorry, and that was okay. But here B times A
Nope.
cannot be done because this is a 2 by 4 with a 2 by 2. The two in ones do not match, therefore cannot be done.
Hold up.
Okay.
Okay?
Wait. Take a moment.
Here's what would happen. Let's say we try to get the 2 by 2, okay? 1, 2, 1, 2. Because the insides don't match, we're not going to get the same amount of elements per row per column. If you go back, how many did we have in a row? How many did we have in a column? So they match, see that? But if we go here, now we're going to take one row, which has 4 elements, versus 2. And they won't match up as I multiply them across. And that's the reason behind that rule. Miss likes to know all the rules. Does that make sense why it doesn't work? Okay? We're cool?
Yeah.
We'll get some more independent practice, but I got to get to the section 4 and section 5. So
8.45.
that was 8.3. The multiplying? That's what we did, yeah. Yeah. Yep. Okay. Here we go. So, we'll do as much of this. I don't think we're going to get to the encoding, decoding thing. But if you want to do that, it's kind of fun. The book is in your math lab. You can go ahead and do that. I want to try to get to both sections. Finding the multiplicative inverse of a square matrix. And then use the inverse to solve equations. And then we'll do the other,
We're doing 2 lessons today?
the last 2, yes.
Are they fast?
There's
Kind
only
of, sort of,
5.
but not really.
Yeah.
If that even makes sense.
Kind of, sort of, but not really.
Kind of, sort of, but not really. It depends on how many questions we have and how many times I gotta tell you to be quiet and give me your. No, what's the word I want to use? I lost it.
Undivided attention.
Thank you. All right, moving on. All right, we're cool?
No.
No, we're not cool. I'm gonna have some coffee.
It's just magics.
Nice hat there, Ernest.
man.
Nice mortar board. Hey, that's not a bad idea.
What?
Like on your mortar board, you know how you can design them and stuff? Putting one of those spiral things into one of the edges, make it look like a notebook. Ah.
Look at me.
I can go? I can go?
No.
Why don't we go? Why don't we go?
I mean, you can go out the door. If it works too. I mean,
You can go.
Yeah? Alright, here we go. Next slide.
Oh my gosh.
Do you guys recognize these? These diagonals of ones? You guys remember what we called that?
Something form.
It was reduced row echelon form.
yeah.
That's only we had the solution part with the augmented matrix. The piece by itself with no solutions in here, these are actually called identity matrices. Identity matrices. Where have you guys heard the identity rule before?
Multiplication. Is it a multiplication?
In some type of math class? If I multiply something by the identity, in multiplication, what was the identity? 1. So if I multiply anything by 1, what do I get?
The same.
I get the same thing back. These are like the identity property. Well, they are the identity property. So this reduced row echelon type matrix, if you multiply by any matrix, you'll get back your original matrix. Really? Pretty cool. You want to see it?
Yeah.
Because I don't believe you, Mr. Munoz. We'll talk about what the purpose is. But you always want to have an identity, right? So let's make up a matrix. Someone give me some elements. 1, 2, what? 3, 7. All right, I'm going to multiply by the 1, 0, 0, 1. Okay? Can I multiply those two? Yeah, they're 2 by 2s, right? What should I get out? A 2 by 2. So let's start here. First row, first column. What's 1 times 1? Plus 0? 1. Let's go first row, second column. 2 times 0? 2 times 1? 2. 2 plus 0 is 2. Let's go to the other one now. Second row, first column. 3 times 1? 7 times 0? So that gives me 3. Second row, second column. 3 times 0? 0. 7 times 1? It's back. So, identity matrix, you multiply by any matrix, you're going to get the original matrix back.
So identity matrix is BIOS.
I did the same multiplication thing as before. So I just did first row, first column type business. Here, this times this. 1 times 1 is 1. 2 times 0 is 0. Add them up, you got the 1.
Oh, I get the 2.
So it's just what I did in the last few minutes, okay? So,
Why is it I2? Is it just because it's 2 by 2? Is it 2 by 2?
I don't know.
I2, I3.
Oh yeah, because it's dimension 2.
Yeah, that's what I thought.
Yeah, and that would be 3. Okay. Why is the identity even important? Well, I think everyone has realized that we can. I think everybody was hearing that.
You should have been in macros class too. Everybody was open
Okay.
facts at the same time.
So we need them. Jesus Cristo. I'm gonna go loco. I'm gonna go loco. Okay. All right. We need identities. I quit. I quit. I quit.
Me too, though, Munoz. It's okay.
Okay. Everyone, I think, at this point understands that everything in math needs to have an inverse of it, right? So you have to be able to undo stuff. Like when you multiply, we know that the inverse is divide. So if I have, if I did something like 1 times 5, I would get 5, right? And how do I get my 1 back? I divide by 5, which is the inverse operation, I get my 1. So everything that we do needs to be undone. Squaring has square rooting, addition has subtraction, so forth, so forth, so forth, right? So if we have a matrix we need to be able to find its inverse, correct? So here's the idea. Here they're telling us that these two are supposedly inverses of each other. If they are, kind of like with the 1 times 5 and then divide by 5, I got the other thing back. If I multiply these two, what should I get? Not 0. I should get 1, which we call, in this case, the identity matrix. So if I multiply this by this, I should get back the identity.
Oh.
Okay? What we need to do right now is confirm that these are in fact inverse of each other's. Okay? So let's do that real quick. Let me erase this bad boy. It's just the identity. Can I multiply 2 by 2?
Yeah.
What should I get? I should get a 2 by 2 back, right?
Yeah.
What? I hope we're that cheery when we're doing finals on December 2021.
What?
I'm gonna be very cheery because I'm like, I got hours to go.
Me too.
So, you guys ready?
Yeah.
Row 1, column 1.
Yeah.
How much is that?
2 minus
2 minus 1 is 1, right? All right. Row 1, column 2.
0.
It's 0. Negative 2 plus 2, right?
what? I thought
2 times negative 1 is negative 2.
And then
And I'm going to combine that with 1 times 2. So that is, in fact, 0. Okay? Let's go to the next one. Row 2, column 1. 0, right? And then row 2, column 2. 1 times negative 1 is negative 1. And 1 times 2 is 2. That gives me 1. So are they in fact inverses of each other?
Yes.
Yes. Yes, they are. Yes, they is. Okay. Now the question is, how do I find the inverse matrix, right?
Yeah.
Let me go ahead and clear this up.
Oh, yeah. Huh.
Can I erase this? Sorry.
Yeah.
Okay. So the question is, well then, how do I find the inverse matrix? Now, just some real quick notation. Guys. Just some notation. If I do have something called matrix A, if I do this, it looks like A to the negative first. I'm talking about the inverse of matrix A. Okay, so just, I think you guys have seen that from before, right?
Yeah.
We call that an inverse? Okay. Now here is the unfun method. 2, 1, 1, 1. Okay. I'm going to create an augmented matrix. And on this side, I'm going to put in the identity for this. So it should be 1, 0, 0, 1, correct?
Oh, do you have to find the other thing?
What?
Do you have to find?
Yeah, so I'm showing you the method for finding the inverse matrix. Okay? So right now I'm starting with matrix A, and I want to convert this into matrix B. Does that make sense?
Yeah.
So, do you guys remember those pesky row operations?
No.
You
What do you mean? I don't really remember much.
guys remember those row operations?
Yeah.
Row 1 multiplied by 2 added to blah.
Oh,
We're using that. And here's our objective. We want the left side to look like what the right side looks right now. So we want the identity matrix to swap. Does that make sense? So we're doing row reduced echelon then.
Yeah.
So I want this 2 to become a 1. I'm going to take row 1 and I'm going to multiply it by 1/2. Simple enough? So that means I've got 1, 1/2, 1/2, 0, and then this doesn't change, so I've got 1, 1, 0, 1, right?
Yeah.
Yes.
Okay, I want this one for those on the video, to become a 0.
Negative.
So I'm going to take, I could take row 1
Multiply by
and add it to row, sorry, multiply by -1 and add it to row 2. Thank you. I'm going to multiply by -1 and then add it to row 2. So in essence, I'm subtracting them, right? So here's what I've got. I've got 1, 1/2, 1/2, 0.
But then you have.
So 1 minus 1 is 0. 1 minus 1/2 is 1/2. 0 minus 1/2 is -1/2. 1 minus 0 is still just 1. Correct?
Yeah.
Cool beans. Now I want that 1/2 to become a, I want this 1/2 to become a 1.
Multiply by 2.
So I'm going to multiply row 2 by 2. So I've got 1, 0, oh sorry, JK smiley face, LOL. 1, 1/2, 1/2, 0. And then so 2 times 0, 0. 1/2 times 2, 1. -1, 2, correct? And now I want the other 1/2, this 1/2 to become a 0. So I'm going to take row 2, I'm going to multiply it by -1/2, and then I'm going to add those values to row 1. Okay?
Yeah.
So what is, this one is okay, nothing's going to happen here now. So let's do the top one. What is half of 0? Add it to the 1. 1. What's half of, the opposite of half of 1? So I've got what? -1/2?
Yeah.
I'm going to add it to the half. I'm going to get 0. -1 times -1/2 is positive 1/2.
Yeah.
I'm going to add that 1/2 to this 1/2. That gives me 1.
And you get a 0.
And then I want -2 times -1/2. That's going to give me a -1. Add it to 0. I've got -1. So now, my friends, we're there. That means that this should be matrix B. And does it match with what we have?
Yeah.
Ah, yeah. There we go, people.
Is there any way to do this on the graphic calculator?
So what's the easy way?
Yeah, you
Yeah.
do all that.
Well, I understand that we need to know this, but like, is there any easy way?
The way we did it up there the first time.
There's a slide. Why would you ask that, Torres? Now you just haunted me. Is there a way I can do my calculator? See, now you got me throwing stuff.
Especially when we're on time constraints.
I am shook right now. You have shooken me.
It's time for a breathing class. Inhale, exhale. Not like that.
Okay. I wasn't going to share this slide,
but
but there is something called a quick method to finding the inverse.
Wait. Because I don't like being in the
Your
middle.
arm counts.
I feel like I'm drinking water and I just like discovered.
All I'm saying, guys, is you're going to be held accountable for all this math.
That's fine.
Oh.
Oh, is this why we had to know how to do this?
Everything has a reason, and it all just kind of folds back on itself. And you pre-calc people, pre-calc comes calc. You're going to need this stuff. A lot of this, especially that trig. When we get to it, make sure you guys really, really. So,
Wait, so we're not at the drink party? This is why we shouldn't do it.
Wait, what type of career? Where's the water?
a lot of it, yeah. You'll probably be using it. Okay, I can change this. I'm going to give you a formula. What? Ah. Oh, that reminded me of Blink. actually. But it came with the Switch, so. But that's why I bought it though, because I knew if I didn't buy it now, I'd have to invest extra money in the game. But yes, Breath of the Wild is next. Alright, and then Odyssey. Okay, so did I put in the slide? Silencio, por flavor. Let's call this matrix A. And it goes A, B, C, D. Okay? Everyone cool with that? If you want to find the matrix, the inverse matrix, here's the quick method. You're going to take 1 over A times D minus B times C. And then you're going to multiply those values by the matrix in this fashion. So there is your quick method, peeps. No. I don't. I shake my fist at you. All right, let's see here. What was our matrix we were working with then?
Do you not like this way?
Oh, I don't mind it. I just wasn't going to give it to you, but
You're welcome, you guys.
you're not welcome, you guys. What was this? Anybody? 2 1 1s? Okay, cool. Is that what it was? Was there a negative in there? I feel like there was.
No, that's in the inverse form, Mary.
That's the inverse?
In the
Oh, that's not what I wanted. I wanted the other one.
No, that's in the inverse.
I want the original one.
That is the original.
Oh,
In the inverse form, there's negative.
okay, so. I can go? Alrighty then. So to find our inverse, we're going to take 1 over the product of A and D.
A and D, so 2.
So 2 times 1. And I don't know if you guys recognize this, but all they're doing is messing is this is a play on the determinants. It's a play on the determinants. And then B times C is 1, right?
Yeah.
So this is going to end up being multiplied by some matrix. I'm not going to worry about that. Actually, we could do it now. Let's see here. So D is going to go in this position, which is a 1.
Yeah.
C is a 1, so now we want it to be a negative 1. A is a 2, that's going to go here. And B is a 1, that's going to be a negative 1, that goes there. Okay? So my inverse is 1. What is that, 1?
1. Oh my god.
Yeah.
So 1 times that, this is my inverse matrix. I'm done.
That's neat.
Well, I was simplifying this fraction and found that it was 1 over 1. So 1 times a scalar of, with a scalar of 1, then I'm just going to get that at the end. Right?
Yeah.
Yeah, it really is. They call it the quick method, but all you're doing is you're doing the discriminant stuff we did in a little formula type thing.
No.
So versus the steps, you'll have this. Okay?
Why don't they use this always?
It's nice to know a variety of things. It's nice to know a variety of things. Because the quick method probably will not work for your 3x3s. So I usually like tools that are universal, like crescent wrenches.
Seriously.
What size is it? I don't know. It just rolls the wheel till it fits. Okay.
We continue, please.
Can I change the slide now? Okay. I want to find the multiplicative inverse of this bad boy. That means I want its inverse. Touche. But like I said, it's nice, you know, if you know it works, then go with that one, which is 2x2, right? Well, technically, you would do the augmented matrix, and you would have 1 0 0 0 1 0 0, 0, 1. Row operate your way through it until the left side becomes the reduced echelon business. Imagine this is the line, my dear.
Yeah, yeah. How would you do with the
You cannot.
I can't find it.
You cannot. The quick method does not work here. So I'm going to show you a quicker method.
Oh my god.
What?
Over the line.
What did you just do?
Why for I cannot minimize? Okay. Somebody in my 6th hour picked up the calculator that had all the matrices on it. Somebody left one in there. No, it was stats. And they're like, this is gross. I'm going to take this back and grab a new calculator. They were, yeah, but they were like grossed out by it, I guess. I'm like, okay. It's just a bunch of numbers there. Okay, so I'm going to go over to second matrix. I'm going to go over to edit. And I have the 3 by 3. So I want to make sure I've got this dimensions 3 by 3. And the elements are as follows. 1, 0, 2. Negative 1, 2, 3. Hey, it didn't go over. I did. There it is. But now it's wrong. That's some lag. 2, 3. And then we got 1, negative 1, 0. So where's my matrix store? It's in matrix A, right?
Yeah.
Is everyone caught up so far?
Yeah.
Okay. I see people writing, so I'll wait a little bit. I'm gonna go to my home screen, and I'm gonna call back that matrix. So I want matrix A. I just want to take a nice look at it real quick. So there's matrix A, right? You guys ready for this? I'm going to go second matrix, A, and I'm going to use the button that matrix is on to take that to the negative first power. And I'm going to push enter, and there's my inverse matrix.
Whoa.
Wow.
What? You are most welcome.
What's
You
that?
cross out with everything.
I can't. I have to teach you the math as well. Calculators are a tool.
Which we will have when we're older.
Do it again.
Tell you what,
Please do it again.
it's right there.
I don't think never in my career I would see numbers again.
What?
Here's the button for negative 1 exponent. Right here. Where my finger's at.
You want to know how I know that?
No, that is funny.
I really hope I created this world so no one else
It's just A and then
I'm not sure what to do. I'm confused now. Second matrix, I want the inverse of A, right? So I'm going to push, look, it's a button. I want the inverse of that, so I'm going to push the negative 1 exponent, and then I'm going to press enter.
oh my goodness.
And there's my inverse matrix. Okay? Moving on. Someone please take this. Take all of my coefficients because we're gonna do something here really fun. Now, this is probably not as cool as reduced row echelon, but this is really, really cool thing too. So I'm going to go over to, oh, my bad. I think a lot more people are starting to see, like, I should invest in one of these. I'm like, Mom, I don't want an Xbox. I want a TIE 4 Silver Edition, please. In the plum.
I'm like, I better see that in my stocking.
We have all the values there?
Yes.
All right, so I'm going to go back. Shh, hiya. Here, check this out. Shh, shut up. Guys, a little professional courtesy here. We're going to solve this using the inverse matrix. So here's what we're going to do. First thing we need to do is to go into our calculator and insert that matrix, right? So now I need it to be a 3x4 again. Oh, what did I do? Second matrix. Over to edit, my bad. And I want it to be a 3x4. So 3, enter, 4, enter. Values are 1, 0, 2, right? -1. No, just the way it is. 2.
3.
I gotta use this negative. -5. 1. -1. 0 and 6.
Yeah.
6. No, I'm back.
This is not Dude, where's my car?
Okay.
I was actually watching that.
Invalid dimension.
Why would it say invalid dimension?
Yeah, that's what I said today.
I don't know what you did. Everyone okay with my matrix in here? Oh, wait a minute. Just kidding. Just kidding. I messed up. Hey, pay attention, please. I was trying to do reduced row echelon. I was going back to the thing I would do the first part. In my matrices, I actually want the 3x3. I only want these pieces. And then I want another matrix to have this piece. So I'm just going to go up to, I'm hoping that this is just going to get rid of that last column. Yeah. So there's the 3x3, right, with all the coefficients.
Yeah.
In matrix,
Make a B.
I'm going to make a B, right. And it's going to be, what are the dimensions of it?
1 by 3.
3 by 1. 3 rows, 1 column. And in here I'm going to put the answers in there, which were 6, -5 and 6, 6, -5, and 6. Okay? Now, can I multiply the two? Can I multiply a 3x3 with a 3 by 1?
Yes. Yes.
Yeah.
What did you do? Oh, yeah. Oh, so now you
So, no, I don't multiply them. I'm going to multiply the inverse matrix by the answer matrix. So I'm going to go second matrix, A, to the -1, and I'm going to multiply it by the answer matrix, which is B, right? So I multiply those two. It's going to spit out a matrix with all the solutions. That's pretty cool. That's pretty cool. Now I'm going to disclaimer this real quick. I would prefer to throw it all into one matrix, go reduce row echelon, and get my answers. But it's just cool to know that the inverse matrix of the coefficients multiplied by the answer matrix will solve the system for you as well.
So x is 4, y is -2.
Yeah, so it would go X, Y, Z.
Wait, so what are those numbers too?
X, Y, Z. In that order. Okay? Cool. Let me move on. I want to make sure I get through this whole thing because we have...
We have 15.
All right. We have 15 minutes?
Yes.
Even better, because I already taught you Kramer's rule.
Oh, you
Do
did.
you guys remember the cross
Hey,
multiply?
go back. What the fuck?
So,
Maybe.
go back to what?
Yeah, go back to that. I was writing it down.
This?
Yeah.
Okay.
I was like,
Oh, wait, that was it for 8.4? So this all for 8, like chapter 8?
yeah.
That was all 8.4. Now let's do 8.5.
Yeah, but like, we did chapter 8. if we do 8.5, we'll be done with chapter 8.
Yeah. That's what I was trying to do. That's what I'm trying to finish, guys. Okay?
So much stuff.
Why so fast? Because we already did a lot of it. Now, we'll talk in a little bit.
Wait, it's a chapter 7 test tomorrow, right? Yep.
We'll talk about that.
Oh, is that what you guys were just talking about?
That's what I want to talk about. That's why fast. And maybe not fast. Yeah, tomorrow you guys are scheduled to take your chapter 7.
That's gonna be a rough.
So can I move on now?
Nah.
Alright, so I'm moving on. So, evaluate the determinant of this matrix. And I already showed you guys this in a previous lesson. What's 10 times 5?
50.
50. Take away 6 times 9?
59. 54.
There's my determinant. There's my determinant.
Wait, was that it?
Yeah. Now, do you guys recognize that from the quick method? Yes, I just showed you that in the quick method.
Wait, that's your what?
This is the determinant.
6, 7, 9.
This is called the determinant. So, what? It's just some fonts and number. Not a purpose we need to worry about right now. When we solve systems, then we want that number. We need that number. Okay. So, here is the slide that shows you Kramer's rule, but it's easier for me to just do it with you. And so I'll do it one time because you guys have already seen it, right? First we find the determinant. Let me put this in the matrix real quick here. So this would be 5, 3, 4, negative 6, right? So 5 times 6 is negative 30, and I take away 12. So my determinant is negative 42. Okay? Now, then I'm going to find d sub x, correct? What am I supposed to do with d sub x? I plug the answers in. So I'm going to change my color here. So for x, now I have 12, 24. The y's would stay the same. And then I do the same process. 12 times negative 6 is, what's 12 times negative 6? How much?
Negative 72.
And then 428s, sorry, 424s. 80, 72?
96, right?
96? That gives me a total of 100, 169? 168? 168. And then what do I do for d sub y? Yeah, so I do the other swap. So I would have, what is it, 5 comma 3? And then 12, 24 in the y solution part. That's an ugly 5. That is the ugliest 5 I've ever seen. Okay, so again, something minus something. 5 times 24. 125 minus 5. Cool. And then 3 12s is 36. So d sub y is equal to?
94.
What is it?
94.
Cool. So now that I have d sub x, d sub y, the solution will be in the form of?
84.
84.
Thanks for feeding me wrong answers, bro. So the answer should be d sub x over d sub y over d. Okay? The negative 30, this one? 5 times negative 6 is, and I take away 3 times 4. Same idea. Every single time. Right here, it's d sub x. That's the solution to the system. That's where the two lines would cross. Yeah, on the graph. Sorry, this y is bugging me. Didn't bug me that much if I could change it the first time, huh? Okay?
Did not go for it almost.
Are you okay?
I'm thinking about the next part because that would be the Do you guys understand what was happening with the cross multiplying stuff business? Okay. Because with the 3x3s, I think I showed you a different method than what the book is calling for. I like my method where you expand the matrix. You guys remember? I can change this, right?
They're almost sisters.
Oh, that's it? What the what? No, go back.
This one curves.
Grammar.
No, that would be the solution right there. Well, if it's like 8/2, then yeah, make it a 4. Yeah, definitely, always. That's just a unspoken rule. You always simplify your answers. You simplify, always. So, can I move on? No. I'll get your question next.
Did it, princess?
We're good here? Okay, on the last one, the 3x3s. Here's your coefficients, there's your solution matrices. Obviously it would be the d sub x, d sub y, d sub z. That's only have 3 equations, 3 variables. I showed you guys how to expand the matrix, right? And then you would have to do the 3. If you want to know the other method, which is using the minors, you have to come see me on your own time, because that just confuses a lot of people. Okay? So it's going to be up to you. If you want to know it, come see me. I'll school you on it. But that's it. We're done. No more new stuff.
Yeah.
Of this? For sure.